Josh, if you end up with the I, do you still want the approximate?
You don't need to do the approximate if you get to the I.
Okay.
No need. Okay. Any other questions?
Can you do number 6?
I can try. Let me see if we have the same number 6.
No.
What is it?
It's 2x squared plus 8 equals negative 3x plus 1.
So this is in the solving quadratic equation section. Was it negative 3x or negative 3x squared? Is that just this? All right, so you're trying to solve this quadratic equation? This is right?
Yeah.
Okay. So what did you do?
I moved everything over.
Okay.
So I did 2x squared plus 3x plus 7. I went ahead and did the...
I agree. And then did you try and factor it or didn't work?
I think I did, but it didn't work out. So I did x equals negative 3 plus minus square root 9 minus 4 times 2 times 7 over 2 times 2.
That's right.
And then I got x equals negative 3 plus minus square root 9 minus 56 over 4.
Yep.
And then I got x equals negative 3 plus minus square root negative 47 over 4. And then my answer was negative 3 plus minus I 47.
Root 47.
Oh, yeah, root 47 over 4. Is that correct?
That's good. Is that not the keys answer?
Well, just like the I kind of like throws me off, and like I get very worried because I know like you said cover the negative sign where the 4 is. On the other step.
Mhm.
Yes. And so like I
Cover
get
the negative sign.
very worried when I'm multiplying my numbers as to what sign is going to be. So like in some like when I covered it I got a positive number. So automatically I assume that's negative, right? Because now I'm putting down that
Yeah.
minus sign.
Mm-hmm.
And if I cover it and it's a negative,
Then it'll be positive.
It'll become positive.
That's right.
Okay.
Now there are some other ways that you can look at it. Like you're always going to have negative 4, right? Just imagine this piece in here. You're always going to have negative 4. Then you're going to have 2 numbers, right? Always. Let's look at all the possible cases we could have. I'm just going to make up numbers, right? 2 and 3. 2 and negative 3. Negative 2 and 3. Let me do this one up here. Negative 2 and negative 3. Are there any other cases I could have? They can both be positive, both be negative. This one could be positive, this one could be negative, this one could be negative, this one could be positive, right? Do y'all see what I'm doing here? Let's look at the answers for each of these. If you cover up the negative, this would be negative and negative, which is positive, and then 4, which was positive again. But then I'm subtracting it. So do you agree this would turn out to be a negative number? I'm doing this for a reason, you'll see in a second. This one right here, covered up, these are all positive, and then you're going to subtract. So this would be minus. Cover this up, you would have what? Those would go together to be a negative, but then you're subtracting it, so it would be plus, and then you could have this case here where you would have what? Negative, and then subtract it, and you would have plus. Now, the reason I'm showing this to you is because some people just get into a habit of just counting how many negatives they have. You know, I mean, you can kind of see here. If you have 2 negatives, right? Just look at this whole expression. Do you see 2 minus signs? You see 2 minus signs? It's going to be positive. If you see 1 minus sign or 3 minus signs. So those are odd, right? If you see an odd number of minus signs, it's going to be negative. If you see an even number, then it's going to be positive. You can just do that if you want something simple, not to even have to think about it. So like here, how many minus signs do you see? Just 1. So it's odd, that's going to be negative. All right, let's get to today's stuff. And what did I say we were going to do today? We were going to graph quadratic functions. And I gave you a 7-step procedure last class. And I said that's what we would start with, right? So you're probably very excited about this. All right, so let's start with, I think I'll make one up. 2x squared minus 8x minus 3. Oh, sorry, I forgot to put f of x here in front. And the instructions here are to sketch this. Now, when we say sketch, that means we want a pretty good picture. Doesn't have to be perfect. We're not trying to land a man on the moon here. Okay, it doesn't have to be that precise, but the picture needs to look pretty close to what it is. All right? So what was the first step? I'll number my steps here as I go through. Make sure it is a quadratic function. Is it?
Yes.
Yes, it is a quadratic function. Second thing. Okay, is this, what did y'all say? I thought you said concave up, concave down. That's a calculus term. Did someone say that? No? Okay, good. All right, concave up, concave down. That's the precise way to say it in Cal 1. But okay, so it's going to go up here. Why? A is 2, right? A is 2, which is positive, and anytime we have positive, we know this little parabola is going to go like that. So I just draw a little picture of what it's going to do. You can say up if you want. The picture is fine also. And on your test, this is what I'm looking for, you know. I'm looking to give you partial credit, so you want to show as much work as possible. 3. Vertex. And how do we find the vertex? Yeah, it's going to give us, the vertex is a point, right? HK. And to find H, I'm going to go over here. We just do negative b over 2 times a. What would negative b be for us here? 8. And I forgot to label this. You don't have to do this at the beginning of the problem, but some of you might find it useful at the very beginning just to kind of write down what A, B, and C are. Again, that's not a necessary step, but you're going to need those things anyway, right, throughout the problem. Okay, so it's positive 8 over 2 times what? 2, which is 8 over 4, which is 2. Now that's nice, what? 2 is a nice number. In examples as we move on, be prepared for these to be fractions, all right? And then things get a little bit nasty. All right, how do we find k? And I hadn't ever done an example, right? But I told you all you do is you plug h into the function. And h for us was what? 2. So that means plug 2 into the function. Does everyone understand that if you get h wrong, k is going to be wrong? Right? Most likely. I mean, you could get lucky and... Pardon me? Okay, in the formula, this is a negative b, right? Negative b, and if b is already negative, it changes it to positive. All right, so let's plug 2 into the function. So I'm going to replace all my x's with 2's, right? There it is. And order of operations and all that, we've done this already. 2 squared, right, goes first. And that's 4, then times 2. So that gives me 8. And then I do this multiplication before I do the subtraction, right? So minus 16 and then minus 3. What's that? Negative 11. So what I can tell you right now is that my vertex is the point 2, negative 11. Right? That's my vertex. And we didn't call on names last time, so let's see. Sir, I have a question. Since you don't have your name tag, I'll ask you. What was your name again?
Zach.
Zach. All right, Zach. Were you here last time? Oh, then I'm asking.
Been here 3 days, sir.
Okay, yeah, all right. Then I probably, did you watch the videos? You did? Okay, so maybe you'll be able to do this. 2, -11 is going to be where on this picture? On that graph, where is that going to be? 2, -11. It's a point on our graph, right? It's our vertex. So what is it? Where is it? Any ideas? No? Anybody? Say it in words. Just tell me like in layman's terms. You're trying to explain to someone, oh, that point's going to be center? Lowest point. Good. Okay, that's going to be the lowest point. Do you agree with that? Because it opens up, we know that that point is that point right there, right? That's the lowest point on our graph. As far as the work, though, we're done, right, for step 2? Okay. Step 3, sorry. What's step 4? What's that? Quick sketch. All right, so that means I'm just going to real quickly draw an X and Y axes. I'm going to plot this point, but very, very loosely. That means 2 to the right, down 11. So my vertex is down there. See how loose I am with that? I don't even care to like count it. I just know it's over and down. And my graph opens which way? Up. Now why am I doing this? Why am I doing this sketch? To see how many X-intercepts I have. And in this case, I do have them, don't I? I have 2 X-intercepts. So I have 2 X-intercepts. Those are exclamation points, okay? I'm telling myself, I have 2. So what is step 5? Or is it still part of step 4? Sorry. Someone read step 4 to me. Do you have the steps right there?
Quick sketch, 5 is how many?
Okay, so 5 is how many X-intercepts do we have? So I should have written that down. Step 5. How many X-intercepts? We said 2, right? If we have 2, go find them, right? If we have 1 or none, we move on. So how do we find the 2 X-intercepts? This is still part of step 5. We set the function equal to 0, right? So I'm going to set the function equal to 0, which means I'm going to set 2x squared minus 8x minus 3 equal to 0. Because I have 2, I need to find them. This is how I find them. I set the function equal to 0. And now I can either factor that, or if it doesn't factor, use a quadratic formula. And I know for sure I should get 2 answers. If I don't get 2 answers, I've done something wrong somewhere, right? Because this shows I should have 2. So x is negative b. What's negative b? 8 plus or minus the square root of 64 minus 4 times a times c, right? Did anybody get the tattoo? Nobody did? Maybe this weekend. There's your quadratic formula. All over what? 2 times 2, right? Okay, did y'all like that thing where we count the signs, or y'all just want to do the number? Doesn't matter to me. You don't care? You do it whichever way you want. Okay, I'll do it both ways. Cover up the negative. 4 times 2, 8 times negative 3. Negative 24, right? And then I'm going to subtract it. So I'm going to wind up adding 24 to 64. I continue. So I have x must equal 8 plus or minus square root 64 plus 24 over 4. So this is where, if you want to do it the other way, you would just say, okay, how many negative signs do I see here? I see 2 of them. If you see an even number, then it's positive. If it's an odd number, it's negative. All right, now this is 8 plus or minus square root of 88 over 4. Hey, doesn't 4 go into 88 and 4 goes into 8? Am I allowed to just take the 4 and do that? No. Remember the rule. You have to do everything up here first, then you can come in with the 4. You cannot do this 4 into that 8. You cannot do that. All right? Do y'all understand why you can't do that? Let me just ask you a quick question. Let me do it this way. Isn't this the same as 5 over 4? This is 5 over 4, isn't it? But if you think that you can just do that, then you're really saying that this is equal to what? 1? 5 over 4 is not 1, right? So that doesn't make sense to do that. Okay, so what do? I look, can I simplify square root of 88? Well, it's not a perfect square, right? So at this point, if you can't break this down, right, we would just leave it as it is. But I think you can pull some stuff out, can't you? But you don't have to. And let me tell you why you don't have to in this problem. Okay, so what I'm getting at is you could break that down to be like what? 4 times 22. Then you could split that up, square root of 4, square root of 22. Then you can make that 2 root 22, couldn't you? And the 22 doesn't break down. So we could do that right here, couldn't we? But we're not going to. The reason is because what are we trying to find? X-intercepts. And those are things I'm going to plot on a number line, right? Does anybody know what this number is just by looking? No, right? This is why the approximation on our calculator of square root of 88 is as good as trying to do that on a calculator. It's going to be the same answer, exactly. So we may as well at this point get our calculators out and take the square root of 88. Go ahead and do that. And you should get, like, what is it? 9.38. And everyone will ask me, you know, how many decimals should we go? Look, 2 decimal points or 2 decimal places, that's fine. All that divided by 4. All right. This is where I did this step right here. Remember this? I'm going to look at the plus and the minus now. Get my 2 answers. I do 8 plus 9.38 divided by 4. 8 minus 9.38 divided by 4. I'm waiting for you to do that on your calculator. Oh, my microphone fell. Okay. Who has the top one? Anyone? 4 point what? 3.4. Okay. And the other one? Negative 0.34. Anybody agree? Anybody agree? Yes? All right. That should be good. Questions? All right. We have found the x-intercepts. So now we move on, right? Was it -3? Okay. Step 6. What's step 6? Y-intercept. And how do we find the y-intercept? You plug 0 into the function, which is always, as long as the quadratic is written this way, it's always just going to be what number? Or what? It'll be that constant at the end, won't it? Because the x's are going to go to 0. It's going to kill everything off except that -3, which is c, isn't it? C is -3, a is 2, b is -8, c is -3. So in this case, it's -3. All right, step 6 done. We good? Plot it. Now that's the last step, right? All right, so here we go. Now here's where my graph needs to kind of look decent, all right? So here's my x and y axes. I'll go ahead and label them x and y. You could also write up here instead of y, f of x, either way. All right, so I'm going to start with the first piece of information I had, which was my vertex. My vertex was 2, -11. 1, 2, sorry, 1, 2, and then -11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, -11. Somewhere around here. And I'm going to label the point like that. The next piece of information, yeah? It is positive to -11. I don't know why I did that. To +11, or to -11. Thank you. The next information that I gathered was the X-Intercept, right? These two things. So 4.34, that's bigger than 4, right? It's less than 4.5, 4.5. So this is why people always ask me, well, how many decimal points do I need to go, right? Like on this, there's no sense in going like 5 decimal places because it's hard enough to graph 4.3, right? 4.34, nobody's going to get that good, right? Unless we've got like rulers and, you know, we've blown everything up real big. So let's see, 4.5's here, 4.3, I don't know, ballpark it, somewhere around there. Can we be happy with that? What I will do is I will label it by making the point 4.34, comma 0. Remember, it's an x-intercept, so the y-coordinate's always 0 at that point. The other x-intercept is at -0.34. So here's -1. -0.34, I'm thinking is right about here. And it's -0.340. Any other information I need to put on the graph? The y-intercept, or my y-intercept was at 0, -3. So if I go 0, -3, 1, 2, 3 here, that point lives on my graph. I will label that point 0, -3. And now I have all the points, right? That's all the information I have. Now, one thing we didn't really talk about last class is that when you have these parabolas, regardless of whether or not they open up or down, both of them will have a vertex, right? And if you can imagine this, it's an imaginary line extending down through the vertex like this. Okay? That is technically called the axis of symmetry, which I'm not going to ask you about that. But the important thing about the axis of symmetry is that this parabola, if you were to reflect it over that dotted line, is a mirror image of itself. So what's happening here on the left is identical to what's happening on the right. It's not possible to get a parabola that looks like this. It goes up like that, and then on this side does this. That is not a parabola. All right? It's got to be symmetric across that imaginary line. So when you draw this, it needs to look symmetric as best as you can do, right? And also, it needs to be a U and not a V. All right? Cannot come down to a point in a corner, all right? Yeah, you need to round it out because This is a different graph, okay? That graph is the absolute value function. It's not a quadratic function. So the way I like to do this is I like to kind of round it off first. I just kind of round it a little bit like this, just to give myself a start. And then from there, I'm just going to go out the left side and it's just connect the dots at this point. You know, something like that. Woo. And on the right side, the same sort of thing. And you just kind of take a step back and you go, yeah, it's good enough. All right? We're done. Yes?
Domain and range.
Yeah, we're not gonna discuss that too much at all. Yeah, on some of the, oh, well, you know what, do they talk about domain range? Oh, you know what, hold on. I take that back. Let's do domain and range. It'll be easy. It'll be easy to talk about. The thing is, we didn't talk technically about domain and range before when we were talking about functions. So we can do it. It's not that bad. Okay, if you go back when we first started talking about functions, domain are the inputs and range are the outputs. These are the x's, these are the y's. All right. So let me explain how we can do this. Remember that this parabola, imagine it keeps going up and going out forever, right? Going up and out forever, out the roof of the building, and just keeps getting wider, doesn't it? So this domain thing is saying, what are you allowed to plug into the function? What are you allowed to plug in? Well, the good news is with all parabolas, there are no restrictions. You can plug anything you want into a parabola. You can plug in the number 2, it's going to spit out a number. You can plug in 3, it's going to spit out a number. You can plug in 4, it's going to spit out a number, right? If I plug in the number 10, is it going to spit out a number? Yeah, somewhere up there, right? So when it comes to this problem, the domain of it, and the domain of all parabolas, is going to be all real numbers. All real numbers. Now there are several ways to say this. That's one way. Another way is to write, I don't know if you've ever seen this, a double struck capital R. That means all real numbers. Another way to write it is what's called interval notation, negative infinity to positive infinity, which means everything on the number line in both directions. And then you can also put x is greater than negative infinity, less than positive infinity. So this is almost the same thing, except you're saying that your x's that you can plug in can be bigger than negative infinity and less than positive infinity, which means everything. That's the domain for all parabolas. Now, the range, on the other hand, are the outputs. So think about the y coordinates. Let's just look, I'm just going to pick a spot right here, this y coordinate. Does my graph ever achieve this y value? Imagine going straight across here. Here and here, don't I get to that y value? Yes? How about if I move down a little bit? Do I get to that y value? Yes? How about here? Here? Yeah, because remember the graph keeps going, right? Here? How about if I go up like, 3,000 feet? Yes? How about down here? No, because I have a lowest point, right? The lowest point's down here. What's the lowest y value I ever have? Negative 11. Right, is the lowest y value? So do you agree that the range of this, the outputs, have to be bigger than negative 11? So how I write that is like this. The range is y must be bigger than or equal to negative 11. That's one way to write it. Does that make sense to you? The outputs, the y values must be greater than or equal to 11. Bigger than means going this way. Another way, in what's called interval notation, you could write -11 to infinity. Now, I don't want to get into this too much, this interval notation, but if you're familiar with it, you can use it, all right? I'd have to spend 30 minutes talking about interval notation if I really wanted to get into it. Just use this one, and you're good. Any questions?
Are you going to put that on the test where we have to write it, the range and domain, or?
I'm more inclined to just ask you to sketch it, steps 1 through 7. Yeah. But as far as interpreting these things, we will, because there's application word problems coming up, we do need to kind of understand what the range is. For example, if we motivated the whole idea of parabolas by taking like a ball and throwing the ball through the air, actually did it with markers, right? Then that point right there, right, would represent the highest point of the ball being thrown through the air. So in terms of like a range, this is the highest point, right? Understand? So we don't need to technically be thinking range, but we need to understand that the highest point has something to do with the range. All right. I'm going to do one more, and then I'm going to let you do one, all right? We're going to sketch this. F of x equals 3x squared minus 7x plus 2. Okay, Amber, you're up. What's the first? You can do the first 2 steps for me, Amber.
Make sure it's a.
Okay, is it?
Yeah.
Okay. Second step. Okay, so what does this one do? Okay, why is it going to go up? That's right. Good. Okay. This number is greater than 0. It opens up. And we move on to Gerald. You're up, Gerald. Take your time. You're still writing some down, or you want me to? We're good?
Step 3, yeah.
Okay.
Finding the vertex.
Okay.
So that's the h is negative b over 2a. So in this one, it would be positive 7 over 2 times 3, which would be 6.
Good. Good. Okay, so you're doing positive 7 divided by 2 times that number, which gives you 6. And then that's h, right, Gerald? And then what do you do with that to get k?
You have to plug, make a function, and then you put that number instead of 6.
Into the quadratic, right? And okay, so this is where things get a little rough for people. It's 3 times 7/6 squared minus 7 times 7/6 plus 2. And Erica, what is that? I'm just kidding with you. It's a mess. It's messy, right? Okay, so look, there's different approaches you can take here, all right? We could work with this all as fractions. In other words, we could square 7 over 6, which would give us, what, 49 over 36, wouldn't it? And then multiply that times 3, and then figure out what this is, and then get a common denominator and put them all together. Couldn't we do that? I mean, it would take a while, but we could do that. But at the end of the day, what is k? H and k give us a point, don't they? And just like with the X-intercepts, It's hard to graph the radicals. It's hard to graph fractions too. So we want this to be a decimal at the end, don't we? So let's go ahead and start now with decimals. So what is 7 divided by 6 on your calculator? What is it? 1.166666. Uh-oh. So we'll just go 1.16. How about that? We're approximating it. Squared minus 7 times 1.16 plus 2. Did you figure it out?
Yeah.
Okay. All right, so at this point, I'm saying that this was equal to this. Now this is approximately this, because I've now approximated with the decimal. And that is just like an order of operations problem. Square this guy first, and then multiply it times 3. When I do this part right here, I get 4.0368. You could say 4.04. That's good enough. Or you could say 4.03. That's not going to affect the answer too much. Minus, and then 7 times 1.16. Get about 8.12 plus 2. That's going to be ballpark area of what it is. So what are y'all thinking? Negative 2.08 or 2.09? All right. If you're within a couple of hundredths of this, 0.8 or 0.9 or 0.7, that's fine. Pardon?
I got 2.1.
10.1?
Negative 2.1.
Yeah, that'd work. I mean, remember you're going to plot this, right? Do you think you're going to be able to tell the difference between negative 2.1 and negative 2.08 on the graph? No, right? But you'll want to label it. And when I'm grading these, I'll see your work and I'll know, you're a little off with the rounding. That's why it's an approximation, right? All right, so remember, as a vertex, the vertex is a point, right? It's going to be 1.16, negative 2.08. That's my vertex. Yes?
So I have a nifty y equals.
Yes?
If I do all of the steps, can I trace it and check it?
Yeah, you can check your work with that. Yes.
So it was different.
What was different?
I lost it. Never mind.
Okay.
I must have been here.
You can double check it.
Mine was 2.05.
Negative or positive?
Negative 2.05.
Oh, but your calculator is doing a better job of approximating than we are. Because when it's we used 1.16, right? Your calculator probably used 1.166666, probably 10 decimal places minimum, and did the same thing here. And then when they did all that work, so, I mean, that's why I'm saying it's going to be off a little bit, right? It's going to be off a little bit.
But if I still show my steps.
Yes, just show me your work. Look, I've had students before, believe it or not, on a test where this is the problem given, right? And I'm not kidding you, this is the answer that they give me. Exactly what I'm going to put up here on the board. They draw a box. And you know what that is? That's their answer. That's all they'll put. That's the screen you're looking at when you graph it.
Right.
That's it. They type in their calculator, this right here, and then it graphs it, and that's exactly what they give me. And that is a sketch of that quadratic function, right? You will get 0 points for that. 0 points. Yes, it's a little off, but our picture is going to be better than that picture because it's going to have all the labels of where everything is, right? What I'm getting at by this is that, and I think we talked about it a little bit, is that if I could say, hey, everybody go buy this $150 calculator, right? Everyone, that's a required part of the class, is that everyone buys that $150 calculator, even though this is the last math class you ever have to take, then we would all be graphing using that. And we'd be using all the features of the calculator to do it for us. But that's not the case. So what's most important for us is the work. That's the part of it that we need to see. All right. Where are we? We're moving up here. You already know what the next step is, right? All right. Daniela, you're up. I don't know what to do. I forgot what I'm doing up here. Quick sketch. Why are we doing that? To see if we have X-intercepts, right? Okay. So when I do this quick sketch, Daniela, what am I putting on here? What's the first part I'm going to put onto this sketch? Okay. So I'm on step 4 here. And my vertex was 1 point, and then down to, so to the right and down again, right? Like this. And which way does it open, Danielle? Up. So if I draw a U going up like this, then it's going to hit, yes? Twice? So we have 2 X-intercepts. That's the answer to 5. 2 X-intercepts. So this is exactly like the last problem, isn't it? Exactly like the last problem. Where are we at? Bianca, you've been out for a while. You okay? All right. So you want to help us with what we do for step 5 now?
Step 5.
Mm-hmm.
Is that how many X-intercepts?
Yep. So we already know we have 2 from this, right? And then since we have 2, what are we going to do?
F of X equal to 0.
Okay, good. And our f of x was, because I erased it, 2x squared minus 7x plus 3, right? Equals 0. Was that it? Okay, so we set that equals 0. What was that? Oh, 3x up out here and 2 out here. Okay, I apologize. All right, now Bianca, I'm going to stick with you. Not to pick on you, but I want to see, since you missed, if you were able to get on track here. How would you do this?
Start plugging into that.
You can use this, yes. You're free to use this, right? Now, let's just take a quick vote. How many of you think that you're just going to go directly to this? Yeah? Anybody going to try and factor it first? Okay, so this is where you have personal preference. In the previous problem, it would not have factored. This one does. This one actually, 3 and 2 is 6, and -7, and the 2 numbers are -6 and -1. So it would work if you did it this way. But the quadratic formula is the fail-safe method. It's going to work every time, right? So I just want to point out that it does factor. But I'll stick with the quadratic since most of you like that. And where are we already? Caesar, you want to go, Caesar? I just want you to tell me what to write in the quadratic formula. Just tell me what I'm going to put in here.
7 plus or minus 49, square root of 49.
Okay.
Minus 4 times 3 times 2 over 2 times 3.
Okay, good. And what is this going to turn out to be in here? -24. So it's going to be minus, right? Okay, good. And what is 49 minus 24, Caesar? No idea? 25? I think it's 25. And you recognize that, Caesar, right? Square root of 25 as being something nice. So that turns into 5. And so now at this point, I can do the 2 different cases. 7 plus 5 over 6, 7 minus 5 over 6. So I'll do that right here. So equals the plus and the minus. 7 plus 5 over 6, 7 minus 5 over 6. What do we got? 2 and 1/3. Which as a decimal is 0.333, but I'll just say 0.33. So those are our two x-intercepts. All right. Where are we? What is it? Step 6. Y-intercepts. Intercept or seps? Singular or plural? Singular, right? We always will only have one y-intercept. One and only one. So step 6, our y-intercept is f of 0, which is 2. Wasn't it? Now the final sketch. Starting with my vertex of 1.16, right? And then down 2.08 or something like that, right? So here's 1, here's 2. Notice that when I'm drawing drawing this, notice that I'm not doing this. I'm not doing like 1, 2, right? Because it's going to be really hard for me to do 1.1 in here, isn't it? And my x-intercepts only go out to 2, right? So my graph's going to be in this little tiny little focused area. Why don't I kind of spread out my vision a little bit? 1 here, 2 here, kind of spread things out. See that? It gives me some room to work with. And down 1, 2, 3. Here's -3. So I was supposed to go out 1.16, somewhere around here, and then down right at about 2. I will label the point 1.16, -2.08, I think we had. Good enough? That look good to you? All right, next thing on here. X-intercepts, which were 2 and 0.333 right here. Man, that doesn't look, it looks, sorry, I'm going to move this over just a little bit. It looks different from this angle than it does straight on. And last thing, y-intercept, which was 2. I forgot to label those points. This is 0, 2. This is 2, 0. And this one right here was 0.330. And I will draw now my parabola, curving out the bottom and bringing it up. Whoa. Whoa. Good enough. So I know as you move through your education, you're going to definitely need to be graphing parabolas, right? So look, here's the most important thing in my eyes about what we're doing. It has nothing to do with parabolas at all. This is a process, right? It's a procedure. It's a 7-step procedure. Can you do a 7-step procedure without like needing a sheet to work off of? Can you kind of get it in your head, run through the process? That's what this is all about, okay? When we were talking about jumping through the hoops, right, to get your college degree, you know, you have 2 people, one with a college degree, one without. That's a college degree right there, okay? All this college degree tells an employer is that you're teachable, that you can learn something, right? And when you take a math class, it's very procedural, it's very analytical, it's very mechanical, and that's a certain way of thinking. And that degree, in some way, shows that you've got a basic knowledge of how to do things like that. Versus without the degree, where it's kind of a gamble, right? You don't know what you're getting unless you know the person. Does that make sense? Okay. Has nothing to do with parabolas and graphing them. Who cares, right? I mean, it's a parabola. Big deal. It's over. I'd rather go look for Pokemon. Pokemons? What's the plural of Pokemon? Pokemon? I'm wondering if I should give you some special cases before we, because I think what we'll do is we'll take a break and come back and do one, let you do one. Let me show you very quickly 2 special parabolas that you could run into. All right, how about this? F of x equals x squared minus 4x plus 1. So I'm going to run real fast through this, all right? You ready? Here we go. Real fast. It is that. It opens up because it's a 1 here. The vertex is h is negative b, which is positive 4 over 2 times 1, so that's 2. K, when I get that, I plug 2 into the function. I get, let's see, 4 minus 8, that's negative 4 plus 1. So negative 3, so I've got 2, negative 3. Okay, with me? Just you don't have to write all this down. Just think through this. 4th step, quick sketch. Vertex is 2, 1, 2, negative 3. Hold on. Ah, shoot. Hold on. I wanted that. You know what? I need this to do something else. Pardon me. Let's make that 7, okay? That's going to change this value. Where's that going to be instead? This doesn't change, all right? If I plug in 2 into this, 4 minus 8, negative 4 plus 3, that's going to be 3 instead, all right? Yes? Where's my vertex? Out 2, up 3? Up here? Which way does it open? Ah, okay. We have no X-intercepts. If I have no X-intercepts, I'm going to move on. 6, Y-intercept. What's the Y-intercept? That I'm guaranteed. 7. And now I go to a sketch. Chances are you're not going to see one of these on your test because it skips an entire process, doesn't it? Okay, so we go here like this. My vertex is out 2, 1, 2, up 3, 1, 2, 3. Here's my vertex. I have a y-intercept of what? 7, 4, 5, 6, 7. I'm not labeling the points. You understand you would need to do that, right? So how am I going to draw this if that's all I have? I'm going to guesstimate. I'm going to use the fact, remember that axis of symmetry and the mirror image? I kind of have an idea of what the left side looks like, don't I? The left side kind of looks like this. So the right side sure as heck isn't going to be this, right? So I can almost, sometimes it helps if you actually draw a dotted line in there. And that helps you kind of gauge distances. Like this distance here has to be the same. This distance here has to be the same. You know, this distance here, that's the same. And so you kind of get that idea of what it does. Understand? Okay, so that's how you do one without, that has no X-intercepts. That would be a special case. One other one I want to show you. Hold on a second here. There. How about that one? X squared minus 4x plus 4. Okay, so it's parabola, right? Opens up. And the vertex, h is negative b over 2a, which is 2. K is, what happens when we plug in 2 here? 2, 4, take away 8, add 4, 0, isn't it? Quick sketch would be next. And it's right here, isn't it? And which way does it open? Up. That means we have how many x-intercepts? One x-intercept. And what I tell you to do if you have one x-intercept? Move on. You already know what it is. If you only have one x-intercept, it was the vertex. So you don't need to find it. You already have it, don't you? That's the vertex. That's the only x-intercept you have. And now let's get the y-intercept, which in this case would be 4. Yeah? So when I go to graph it, just like the previous problem, I go out, let's see, 1, 2, here's my vertex, which also happens to be my x-intercept, and my y-intercept is up here at 4. And then I could draw the left side out, and then try and mirror it over and draw something like that, right? So like that, and you're done. Got it? I'm going to give you your break here in 1 minute. Things to be careful with whenever you're going to graph these. And again, this just goes off of the history of me seeing things. What if you're going and you do all your work, steps 1 through 6, and you go to draw your graph, and you get this situation right here. You've got your vertex here, and you've got an x-intercept here, and an x-intercept here. And let's say you have a y-intercept here. Yeah, what does that tell you? Something is wrong. Something in your work is wrong, okay? Do not do this. You're laughing, but trust me, I've seen it, okay? Don't just put dots and then try and connect them together. That's not what this is. Your graph has to look like a parabola at the end. And if something looks off, most likely something in the math is off. All right? Okay, we're going to take a break, and then we're going to come back and we're going to talk about applications, which means word problems. It's on my watch 1:38. I'll be back at 1:48.